Alright, this is the Chapter 3 review packet, Algebra 2. Number 1, the scale change has the effect on a graph of stretching horizontally by a factor of 2 and shrinking vertically by a factor of 3. We want to write a rule. Well, we always write rules with x comma y. Arrow, since this is a scale change, we use s. If you're stretching horizontally by a factor of 2, it becomes 2x, and shrinking vertically by a factor of 3, it's going to become 1/3 times y, or y divided by 3. There's your rule for number 1. For number 2, what scale change effect? Same question, only you're stretching horizontally by a factor of 5, so x comma y, arrow, scale change, 5x, comma, and then stretching vertically by a factor of 6. Vertically is y, 6y. Okay, number 3, give an equation for the parent function of this. You'd have f of x equals the absolute value of x. And then state a rule. I'm sorry, I said absolute value, didn't I? That's a square root of x. Sorry, got nervous. Okay, our rule here would be x comma y, arrow. And then this is a translation because we're adding and subtracting. So we do the opposite. This is going to become x plus 3 comma y minus 2. Again, you switch the rule and the equation. Since it was x minus 3 in the equation, it becomes x plus 3. And the negative 2, you have to think of that as it was y plus 2 over here, so we switch it to get negative 2. Okay, for 4, 5, and 6, you do the same thing with both of them. Negative 6 comma 5, you just plug negative 6 in for x and 5 in for y. Negative 6 plus 3 gives you an x coordinate of negative 3, and 5 minus 4 gives you a y coordinate of 1. That is the new point. Number 5, my x asymptote at negative 3 is only affected by the x plus 2, so once again I just plug that in. I get a new x asymptote of negative 1. And my y asymptote, y equals 5, I do 5 minus 1, so that becomes 4. So my new asymptotes are x equals negative 1 and y equals 4. Number 6, the vertex of a graph is negative 4 comma 3. Well, vertexes or vertices are also affected the same way. You just plug them in. Negative 4 minus 5 is negative 9. That's your new x. And your y would be 3 minus 2, which is 1. So your answer for number 6 would just be that. Okay, for number 7, you had to look at how data is affected by translations. If you read through this, you've got a research team. They go 36 randomly selected hospital employees. Well, they go and they subtract 91 from the amount of radiation from each one. So this is a translation, not a scale change. If we subtract 91, translations only affect mean, median, and mode. Everything else stays the same. So the mean was 151. We do subtract 91 from that, and we get 60. Okay, which that's just 151 minus 91 equals 60. Standard deviation is not affected in a translation, so standard deviation stays the same. Now, you weren't given the standard deviation. However, standard deviation is the square root of variance. So using my calculator, the square root of 1089 is 33. So the standard deviation was 33, and it stays 33. The minimum value is 120. Well, I would subtract 91 from the minimum value. 120 minus 91 is 29. And the range is found by doing maximum minus minimum. So 211 minus 120 is 91. If I subtract 91 from the max and the min, I'm still going to get a range of 91, so it goes unchanged. It would still be 91. For number 8, same type of question, only now we're adding $1,020 to each month's budget. So again, it's a translation. The mean, median, and mode are affected. Nothing else is. The mean was 15,223. We do add 1020 to it. So for the mean, we've got 15,223 plus 1,020. Which is 16,243. Standard deviation, again, doesn't change, but we have to square root the variance in order to get it. So the square root of 8,100,801 is 901. That's the standard deviation, unaffected by the translation. The minimum value, was 12,860. We do have to add the 1020 to it, so 12,860 plus 1020. I'll write that down. 12,860 plus 1020 equals 13,880. And then the range, max minus min, again, goes unchanged because you're going to add 1020 to both of them, which you can if you want, but I'm just doing 21,004 minus 12,860, again, on my calculator. Here, you can see it. Look at that little calculator there. Oh, 8,144. How nice is that? That's pretty nice. Okay, done with page number 1.